Hello everyone. So for today's lesson, we're going to move on and start looking at the SQL syntax for how to create tables. So it's a pretty simple topic. We're going to go through, I'll show you how to create some tables. We'll go through some of the different options, the different data types that are available. We're also going to look at constraints, basically special properties that various columns can have when we create tables. These constraints are set up to basically prevent someone from entering invalid data. So doing things like having a primary key, or also making a foreign key constraint so that the data in one table has to match with another. Also, you can have a check constraint, which makes sure that your values are within a certain range. There's also a not null constraint and a unique constraint. So we'll be looking at those. And that's pretty much the lesson today. Once we get through this, then we'll pretty much be ready to start tackling the first assignment in this class. So I will be posting that shortly as well. All right, so let's look at the notes. I will be posting these on D2L. D2L is down right now, so I wasn't able to do that, but I'll get these posted really soon. So let's just go over the first few slides. They just kind of cover some of the theory that we'll need to know, and then we'll do some examples creating tables. Okay, so just some rules in terms of the syntax here, that table and column names, they can be up to 30 characters in length, and they must begin with a letter. So, you know, obviously if you're gonna use underscores or number signs, they can't begin the actual word. No blank spaces are allowed, and all table and column names must be unique, and you can't use reserved words. So obviously very simple. And if you made a mistake and accidentally violated one of these, you'd get an error message telling you, most likely. All right. Okay, so in a table, let's say we have a table of vendors, for example. We would have a vendor ID, we would have a company name, we would have an address, a city, postal code, okay? So for each of these, we would have to choose a name for each of those columns, and then we'd have to pick a data type that goes along with each of those names. And for some of the different data types, we'd also give it an additional property, which would correspond to the maximum length or size of that column. And it's important that we pick the right values, because we don't want, I mean, for example, if we have a postal code, we would want to restrict that to only 6 characters. If we allow it to be more than that, then it's going to be very wasteful of our computer space. Okay, so there's 4 basic data types: varchar, char, number, and date. So let's just take a quick look here. This note kind of explains them. Varchar is variable length, so you can specify a maximum size, and then if you enter less characters, it'll only use up those characters. Char, on the other hand, is a fixed character length. So if I specify, for example, char 9, then even if I only enter 2 characters, it's still going to allocate and basically use all of the space for 9 characters. And in that situation, it'll add spaces to the right of any characters I add, if I add less than 9 in that case. Okay, next up is number. So number basically can be either an integer or a decimal place number. And when you specify a number, there's 2 parameters you can pass in. One of them is going to be the precision. So that's basically how many digits can it represent in total. And then the second parameter is going to represent the precision, or sorry, the decimal position. Wait, the scale. Okay, there we go. The scale, and that's going to indicate how many positions to the right of a decimal, how many digits I can have. So there we go. So once again, if you're using a really large number, you're going to have to make sure you give it enough precision so you can store all the values you need. All right, next up is date. And date is going to store basically just date values, and it can store them in pretty much any range of dates that we would come across. And the default date format is date in terms of two digits for the day, then a dash, and then 3 characters for the month, a dash, and then 2 characters for the year, according to these notes. So that's the default value. Now I did run into some problems where that was not the default value that was showing up when I was trying to enter in my values. So I had to go and actually set that as my value when I created those tables through some scripts in the last video. Okay, so let's move on now. So we know what the 4 different types that we can use for our columns. And here's the basic syntax for creating a table. The command is create table. We give it a table name. And then we go through and we specify each of the columns that we want in our table. And for each column, we give it a column name, then a data type, and then optionally, we can give it a default value. So in other words, if no one entered anything for that column, this would be the value that would be entered into the database. Okay, so here's a simple example. We see create table account manager, and from there we see that we have several different columns, and those columns are all very simple. The only thing that's interesting here is we have 2 default values. You'll notice for the AME date, it's a date column, and it has a default of sysdate. So in other words, it's going to take today's, whatever the current date is, and enter that if a value is omitted for that column. The other one we have is we have a number, which has a precision of 7 and a scale of 2, and it's using a default value of 0. So 0 is going to be entered into the database if nothing is entered when a row is inserted. Okay, so we just talked a little bit about the default keyword. So basically, as the notes say, it's going to assign a default value if nothing is entered in that column. Okay. So let's do a quick example. I'll fire up my SQL developer. Okay, so I'm just seeing the scripts that I used last time to create the different tables. So that's a good resource here. You can go back and look at each of these scripts and the different values they have. So for example, here we have a table employees. And the first column is employee ID, and it is of type varchar with a maximum size of 5. And this has a constraint of not null. And also it is a primary key. Okay, so a couple constraints are added for that one. We also have several other columns, and some of them also have constraints. And let's see here, what else? Okay, so yeah, each of these tables pretty much has its own columns, and then constraints come with a lot of those columns. So let's open up a new file here. I'm going to create a database file. All right, so now one thing I should mention, I do have the book open here, and I'm the notes that the PowerPoint slides, they aren't actually directly from the book, but the book in chapter 10 goes through and really explains in great detail all of the different steps involved in creating tables and the different options that go with it. So that's chapter 10, so that's what I have actually open here. And let's create a simple table here. So I'm looking on page 315. And there's a command here. I can create a table. So create table vendors. Okay, and inside these parentheses, I'm going to enter in my columns. So vendor ID, and this is a number. Now, if you don't enter any parameters for the precision and the scale, then number is just going to take up the maximum size. So that'll, in fact, I believe it's 38 digits. So I should probably go and pass it a value here. So I'll pass it, let's say 5 for my precision. Okay, and the other value is vendor name, and this is going to be varchar2. And it has a maximum of 50 characters. All right, now there are some primary keys and constraints, but we're not there yet, so we're just gonna do this really simple example. So I can now run this. So I'll put a semicolon there as well. Okay, so we see that that worked and my table was created, in fact. So now I can do a select star from vendors. And of course, I won't get anything because I haven't actually added anything into the table. So if I want, I can also go and look at my tables here, and I'll notice I now have a vendors table. Right? And for data, if I want, I can insert a new value here. And now when I go and run this query, there we go. I have an actual value of vendor ID 121 and the vendor name is Eric. Okay. All right, so let's switch back to our notes here. And the next thing I notice, it says figure 3.3 shows how to list all of your tables using the data dictionary table, user tables. So data dictionary is a concept that we'll be discussing throughout the course. And it's basically SQL commands that give us information about our database. So instead of retrieving information from a table, we can retrieve information about the properties, for example, of our all of our tables. Or we can look up information about different constraints or views or whatever. All of this information can be located through what's called the data dictionary. So the command here is select table name from user tables. So I can go and execute this as well. Select table name from user tables. And there we go. What we see, the output is all of the tables in our database. And we'll notice that we have a vendor table. Okay, it should be there. I can't see it. Good, okay. Number 8 is vendors, okay? All right, we can also use another command in the data dictionary called describe. And so if you have a table you're working with and you wanna quickly learn what the actual column values are, you can use the describe command. So I can do for example, describe vendors. And there we go. Basically, it shows the two columns. Vendor ID is a number, and vendor name is varchar. And I'll just do one more. I'll go describe B underscore books. And there we go, right? So any table, if we want to quickly look up what the columns are, we can go ahead and do that. All right, so now we're moving on to constraints. Now, one thing as I mentioned, chapter 10 in the textbook goes through and does a really good explanation of the constraints. These slides just kind of do a really brief overview. So I do recommend, if you have the book, chapter 10, just read through it. Lots of good information there. Okay, so including constraints is just something that you're always going to want to do in your tables. If you don't have any constraints, then basically people can enter invalid information. They can enter information in one table that doesn't match in another table, and the database is not going to function properly. So it's really important to make sure you're always adding the correct constraints when you're designing your database. All right. So constraints also, they'll help identify errors when someone's entering data. Another thing that's important when you set up your constraint is it's recommended that you give your constraint a name. Now, in some situations, you can get by without providing a name, and that means the database will provide a name for you. But in those situations, if you go with the default name, when someone violates one of the constraints, they're going to get a really, really unintuitive error message. Okay, by naming it your constraint, they'll see the name of that constraint and they'll have a better idea of what they've done wrong. Okay, so let's talk a little bit about constraints here. So the constraints that we'll look at today, primary key, that basically means that you have a unique identifier in your table that has to be not null and also has to be unique, okay? And when you mark it as the primary key, there's going to be special index optimizations that your database will do so that you can very quickly retrieve information about anything using that value. All right, next one is foreign key. So whenever we have a column in our table that matches a primary key in another table, we should mark this as a foreign key. This way, we ensure that any data in our table matches a value that's in the other table with the primary key. Okay, unique. This just means that there can't be more than one of the same value. Now, it turns out that you can allow null values, and null values are not considered the same. If you need to have both unique and not null, often that's the property of a primary key, but you can also mark it unique and not null. Now the last one I'll mention is check, and a check constraint just means that a value is within a certain range. So could be that you're entering days of the week, so your check constraint says that the day has to be Monday, Tuesday, Wednesday, Thursday, or Friday. You won't allow anyone to enter Saturday or Sunday, for example. All right. Okay, now here it just mentions when you name your constraints, it's a good idea to use a prefix such as PK underscore or any of those that are listed there. It just makes it easier to identify the type of constraint. Now, it turns out there's two types of ways you can enter constraints. You can do it as a column level constraint or a table level one. For the most part, it's personal preference which one you use. Table level constraints tend to be a little bit more powerful. The one thing that table level constraints can do is they give you the ability to reference more than one column. If you use a column level constraint, you have to place the constraint right after you declare the column. So obviously you can only have one column value in your constraint. When you use a table constraint, you can have multiple columns referenced in the constraint. So we'll see examples of both coming up here. Okay. So primary key constraint, you would use a syntax and this syntax is very similar for any of the types of constraints. You would say constraint, then you would give it a name, then you would say that the constraint is of type primary key, and then you would indicate what columns are involved in the primary key. So let's see an example here. We have a table colleges, and we have a college code, we have a college name, we have a city, a province, etc., etc., etc. We get to the bottom, and now they're creating a constraint. Now this constraint turns out to be a table level one, I believe. I might be wrong about that, actually. I better just double check this. So table level constraint, I believe it is a table level constraint because it comes after the column. So the column is declared up here. And when we get down to the bottom, now we actually put in our table level constraint here. So we say constraint, and we name the constraint colleges, college code PK, and the type of constraint is primary key, and the college code is the actual column we're going to use. So there's an example there, creating a constraint. Okay, so foreign key constraints are going to be very similar. The syntax is basically the same. You say constraint, you give it a name, but this time you say foreign key, and then you indicate what column. Now the difference here is you have to say what table and what column it references. So you would say references, then you would specify the name of the table, and then you would say the name of the column that it actually references. So here's an example here where we have a table salary history. We have employee ID, which is going to be the primary key, I believe. Yes, it is. No, it's not. Employee ID and salary start are the primary keys. And now we have another constraint, and this is salary history employee ID foreign key. So that is going to say that employee ID must reference another table, employees, where the employee ID is the primary key in that table. In this table, it's a primary key, but it's composite, okay? So it has to match with the other table. All right, now keep in mind, these, once again, are table level constraints. We should see an example. If we don't see one here, I'll just pick one from the textbook that shows a column level constraint. Okay, so let's keep going. Okay, so let's talk a little bit more about a foreign key constraint. So when you have a foreign key constraint, one thing that can come up is, let's say I have my employee table and I have my salary history table, okay? And we know that the salary history table has a foreign key that references a primary key in the employee table. What would happen if I went to delete that employee from the employee table? Well, it turns out I would get an error message basically saying we can't delete this employee because their data is stored in another database and there's a relationship with the data. So that's one thing that can come up, and usually that's a good thing. You don't want to just delete something and then break a reference somewhere else. So if you find yourself in that situation, there is a command you can use. When you delete a row from the employee table, you could write onDelete Cascade. And what that means, or sorry, no, I'm mistaken here. When you set up your constraint, you would then say onDelete Cascade, okay? So this would be for the salary history table. After you create your foreign key, while you're doing it, you would say onDelete Cascade. What that means is that if someone deletes that employee, then any entries that reference that employee in the salary history table will also be deleted. Okay, so it says here, this will delete all occurrences of employee ID in the salary history table when a row is deleted from the employee table. So the corresponding row in the salary history table will also be deleted. All right, so other constraints here, I'm not going to spend too much time on going through these. They're very simple. Unique key constraint basically means that you can't have two of the same value, although it will allow you to have multiple null values. And you would just enter in constraint, you'd give it a name, you'd say unique, and then you would specify your column name. Okay, check constraint is going to make sure that your value is within a certain set. So basically you say constraint, you give it a name, check, and then you have to give it a condition. And this condition is going to be very similar to what's called a where clause. So let's see an example here. So right here we have a few constraints. This is a table work status. We have a status code. That is going to be our primary key. We have a status name, and that is varchar 8. And status name is also, there's going to be a constraint here as well. Status name has to be either, so it says check status name in, active, or inactive, or null. Okay, so we're basically restricting it to a range of 3 values. And we also have for our status code, even though it's the primary key, we also have another constraint which says work status, status code check. That's the name of the constraint. We gave it that name. And the status code has to be either 0, 1, 2, or n. Okay, so another really useful thing for a check constraint is, for example, if you have a table that is related to orders, and you want to make sure that when you enter information, a common mistake could be that the dates get mixed up and the person enters in the order date where they meant to enter the ship date. So you can have a check constraint that checks that the order date comes before the shipping date, which makes sense. How can you ship a product before it's ordered? Okay, so this this note here I think is slightly misleading. It says a table can also use table constraints instead of column constraints as shown in table work status. When I look at these constraints though, the first three are column constraints. So you can see here that they declare the table work status. And the first column is status code. It's a char with one character. Then they declare their constraint. And the constraint is CK work status status code. And the constraint is a check constraint. And the status code has to be one of 0, 1, 2, or n. So they basically declared the constraint in line with the column declaration. And that's different than what we saw previously, where they first declared the column and then they did the constraints after. So these are table constraints here, where here, these are column constraints. Now the last constraint they have, this would be a table constraint. Constraint primary key work status, status code, and the primary key is status code. Okay. All right, so moving on, not null constraints. So basically this is a type of constraint where the value has to exist. You can't leave it empty and just have it be an empty value like null. There has to be something there. Okay. So yeah, let's take a quick look here. We have an overall example. So this one, they're creating a table called account manager. You have a couple columns here, AM ID, AM name, and then we have a constraint for AM name that's not null. Then we have a date. We have a default value for the date. We have a region. We have a department. The department has a constraint, and that means that, okay, no, the department does not have a constraint. So now we're looking at table constraints. So we're done declaring the columns, and the first table constraint is that the primary key is AM ID. And then we also have a check constraint that region has to be either North, NS, W, or E. And we also have a foreign key that department ID, that column, references the department table and references the column department ID, the same, column name from the department table. And last, we have a unique constraint that AM name has to be unique. Now, notice here for the unique constraint, they did not give that constraint a name, okay? It's optional whether you do it. And in this case, they just said, we'll let the database pick the name for the constraint for us. Okay, next up is dropping a table. So if you've created a table, maybe you're just practicing creating tables, you probably want to drop that table, remove it, and then you can practice creating a table again over and over. So the command there is pretty simple. It's drop table, you give it a table name, and then optionally you can give it this optional parameter, constraints cascade. So this is very similar to the on-delete cascade for the foreign key relationship we talked about earlier. What this means is that if I drop this table, but I have a foreign key in another table, then what is that going to do then? Let's see here. So both the table structure and contents are deleted. Okay, the constraints cascade option deletes the foreign key constraint in the child table. Okay, so it's going to simply just remove that foreign key. So I have a table, let's say I have a table employees, okay? Then I have another table called employee salary, okay? And the employee salary table has a foreign key, which is employee ID, that references the primary key in employee. So when I delete the employee table, if I don't say constraints cascade, I'm going to get an error. But if I do say constraints cascade, then what that means is the foreign key constraint in my employee salary table will simply be removed, and that will mean that the value will basically be can become null at that time. So you have to be very careful with deleting data like this because it could break your database. If I were to do that, I would then have employee salary rows that would have null values for the employee ID. Okay. So one thing that we'll do when we create tables is we're going to use scripts. Now, the scripts that I posted on D2L, I used those in the last video to create some tables that we can practice with. So when you're going to do that, usually it's a good idea to create a script that's going to have a bunch of create table commands. Now with this though, you're also going to want to have a bunch of drop table commands. That way, if you want to rerun the script, the first thing you're going to want to do is remove the tables and then re-add them again. So often you'll have a series of drop tables and then create tables. And I might as well, while I'm talking about this, I'll just pull up one of these. So we see here with my bookstore SQL file, the first thing I do is I drop a bunch of tables. Now notice I am using the Cascade constraints parameter because I know that I want to just clear everything out. After I'm done that, then I go and I create the tables. Now one thing that occurred the first time I ran this, I would have got a bunch of errors because there weren't actually any tables there. If I run this now, of course the drop table is going to work because those tables exist. So there are actually ways you can, fix this up so the first time you run it, it won't actually delete anything. And that's what the slide here shows, is that you can, instead of just using the command, you can use what's called a subquery. So you can say if exists, and then you would do select star from user tables where table name equals, and you give it the name of the table that you're going to remove. And only if that table previously exists will you actually drop it. So that way you're eliminating some errors the first time you run that script. Okay, so this is just explaining what I just talked about there. Okay, so let's just do a couple really quick examples just before I wrap things up today. So I've got my SQL file here, I have my vendors table. So let's modify this. So let's try dropping the vendors table. So I'm going to say drop. Just going to look back at my notes here, make sure I'm doing this right. Drop table. Vendors. Okay, so for every time I run this now, it's just basically going to drop the table. I'll just clear out my comments here and I'll run it again. So it's going to drop the vendors table and then it's going to create it. So this is good because now if I want to modify the vendors table and practice doing some constraints, I can do that. So let's add a constraint. I'm going to add a column level constraint for the vendor ID. So for vendor ID, I'm going to say constraint. And I'm going to name the constraint vendors underscore PK. And then I'm going to say that this is of type primary key. Okay, so there we go. Now I've added my constraint. So I'll try running this again. And there we go. It successfully drops it and re-adds it. And it's now setting up to use that constraint. So once again, I can add another constraint. Let's say for vendor name, I want to make sure that they enter a correct vendor name. So I can say constraint, and I would say then vendor name, not null. So I'm basically prefix or postfixing it with that. And I'm going to say that the type is not null. Okay, so once again, I'll run this and I'll make sure that everything works, and there we go. It's correct, okay? So those are just two examples there. Now let's say I want to modify this, and instead of using a column constraint, I'm now going to go and place a table constraint. So I would do this as such. I would go constraint vendors underscore PK, and it's of type primary key. And the field or the column I'm going to use for it is vendor ID. Okay, let's try running that. Okay, I did something wrong here. Doesn't seem to like primary key. Oh, it's because I put an underscore there. Okay, there we go. So I'll run that again. And there we go, it created the table. Now the first time through I did get an error because it didn't create the table the previous time. So that table didn't exist. Okay, so I'm gonna wrap things up for today's video. So I will be posting the first assignment. It's a very, very basic assignment. You're just gonna create a series of tables. You're gonna specify the correct data type for each of the columns, and then you're gonna specify the various constraints on each of the tables. So please look for that on D2L. I'll have that up for today. And that'll be it. I'll have a good weekend, and I'll have a new video for you guys early next week.